All right, we are going to start with example 5, saying Sarah and Morgan start running around the track at the same time. Sarah's moving faster, which means Morgan gets left behind. So this is a fall behind problem. So we subtract their distances, and then it should be a distance between them is 4.5. So that's going to be our setup. Looks like we're going to put 10 in Sarah's box, and we're going to put 8 in Morgan's. And because it says they're starting at the same time, they both get the same thing, which is t. So now we just kind of substitute that in. So Sarah's distance is 10t, Morgan's is 8t, and I want to know when they'll be 4.5 miles apart. So it looks like they'll be 4.5 miles apart after 2 hours and 15 minutes. All right, the next problem is the compare to find. So it's going to talk about 2 different trains. They're not like going the same path or opposite directions. They're just kind of doing their own thing. And then we're going to kind of compare the answers. So with the express train, if you were to make a table, so you would have express and local, and you'd have rate and time for both of them. The express train is going 80 miles per hour, but we have no idea how many hours it's traveling. The local train is going 50 kilometers per hour. And all it says is it's going to take it an hour and a half longer. So we'll have to take the express train's time and add an hour and a half. And that's the total time for the local train. So it is a comparative find. Basically, it says they're traveling the same distance. So that means the distance of the express train should equal the distance of the local train. So we're going to do 80t equals 50 times t plus an hour and a half. All right, and then you can pause the video and go ahead and solve it. Hopefully you got 2.5 hours, and normally we'd be done, but I always like to reread the question and make sure I answered it. And the question is asking how far apart are the cities? That means distance-wise. What are the distances? So what I'm going to have to do is rate times time, and you can use either one because they travel the same distance, but I would probably do 80 times t, or in this case it's 2.5, and do it that way. All right, so for the last 3, A, B, and C, we're going to set them up together and fill in tables and decide what kind they are together, and then you're going to solve them on your own. So you might as well go ahead and draw some tables. All right, it looks like we have 2 trains, so we'll call the first one train 1 and the other train 2. It says they are traveling north and south, so opposite directions means it's a work together. First train is going 50 miles an hour, second one is 60, and they left at the same time, so they both get T. So work togethers would require adding for the total distance. All right, letter B, again, we're going to start with the table. It looks like we have 2 groups of hikers, so we'll call one of them group 1 and the other group 2. It says the first one is going 1.5 miles per hour, the second one is going 2 miles per hour, and it says at 7 a.m. they both started hiking, so that means they get the same time. The last thing is we have to figure out what type it is, and when something comes apart and heads towards each other, that's opposite directions, that is a work together. So again, we will be adding, and it looks like the total distance apart was 21. And letter C, we have a table. Do rate and time, and it looks like we have a runner who is going to run a certain distance and then turn around. So we'll call the first distance his going to trip and the second his going back trip. So it looks like he starts out at 9 miles per hour. And it says he runs a certain distance, turns around, and he slows down to 6 miles per hour. So there we go. It does not say how long he ran on his first trip, so we'll have to use T for that. Now here's where you gotta be careful. It says the round trip. So the total trip was 2.5 hours. So these two blocks need to add to make 2.5 hours. And the only way that can happen is if we put a 2.5 minus T in this space. You just think about that. You're taking the total time and subtracting the portion that you've used, and that should give you the remaining time. And it's obviously not a work together. It's not a head start because someone can't start ahead of themselves or any of those. So this is going to be compare to find. So we're going to do D1 equals D2. And that should make sense because the way, if he ran 10 miles, then he has to go back 10 miles. So his distances should be equal. So go ahead and pause the video and see if you can solve this real quick. All right, so problem A, we should have gotten 2.5 hours. Problem B, we should have gotten 6 hours. And problem C, you have to be careful because when you solve, you get 1 hour. But the question says, how far did the runner move before he turned around? So that means what's the distance of his first trip? Well, to get distance, you have to do rate times time, but now we know the time is 1 hour. So if we do 9 times 1, we get 9 miles. So that runner ran 9 miles before he got tired and turned around.